विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru. Garden City University, conquer we shall all adversity. Together we stand in unity. Together we strive for prosperity. GCU, emphasis on life. GCU, emphasis on life. In today's episode, we are honored to introduce Dr. SV Diwakar, an accomplished scientist and assistant professor at Jawaharlal Nehru Centre for Advanced Scientific Research, Bangalore, India. With a PhD in mechanical engineering from IIT Madras, Dr. Diwakar specializes in computational fluid dynamics, microgravity science, interfacial science, and non-linear acoustics. His journey has taken him from India to France and Germany, where he collaborated with leading research institutions. His expertise spans multi-phase flows, heat transfer, and acoustic phenomena, with numerous high-impact publications and patents to his name. He is also the director and chief technical advisor of Rugna Abhilekha Private Limited, working on groundbreaking air separation technology. Dr. Diwakar started off by giving a brief introduction about himself and his research and how he ended up in JNCASR.
Hi, I'm Diwakar, faculty of the Engineering Mechanics Unit of JNCASR. A little bit about me. I did my doctoral studies from the Indian Institute of Technology, Madras, where I worked on developing computational algorithms for understanding multi-phase flows. So multi-phase flows are fluid flow phenomena that involve more than one phase, like liquid, gas, solid, or liquid type of systems. And subsequent to my PhD, I did a postdoctoral fellowship at the CNRS, which is the French Center for National Research, or the National Center for Scientific Research, particularly in a lab in Lille, north of France, where I did develop many experimental payloads that were being flown in the parabolic flights, where we do try to emulate zero-G conditions for a small time and try to understand different phenomena that could include fluid flow, biological systems, combustion systems, and etc. Right from my childhood, research has been a passion for me, and I've been always saying that I should become a researcher at some point in time. And even though I in between had a brief tenure in industry, but every time I had come back to research because that's my fundamental passion. Of course, India is, has a very rich research culture. We have so many inspirational scientists like Ramanujan, C.V. Raman, etc. So, growing up, I've read about so many of these legends, and that has inspired me to, continue the research path.
He then explained fluid mechanics to us in layman terms for a better understanding into the subject.
So, fluid mechanics is around us and is within us. Okay. So what is it? So before going to fluid mechanics, one should ask the question: what is a fluid? So in layman terms, we say anything that flows is a fluid. So that means even a traffic flows. You can model traffic flow as a fluid dynamical problem. Okay. So fluid mechanics is basically understanding systems that deform continuously. Okay. So that's the prerogative, but then it is in part of nature. We breathe. So there is a process of airflow inside us. There is transfer of oxygen through the lungs, and then there is transfer of carbon dioxide outside, and then we exhale. So whether we understand fluid mechanics or not, it's a part of us. Okay. So in the same way, there is rain, there is flow of water, there is flow of rivers, there is flow of oceans. Okay. So it surrounds us, and it's quite challenging because understanding this phenomena has been there for quite some time, but it's not been well understood. Still, it's open to so many research questions, and that's what we are trying to understand. Of course, see, from the aspect of drug production to drug delivery, that means once a medicine is injected in your body, okay, how does it go to the targeted system? Okay, so there also fluid mechanics plays a role because sometimes it's carried by the blood. Okay, so how do you understand whether the transport of the drug happens or it gets absorbed somewhere in between? How do you regulate? How do you understand these things? Of course, fluid mechanics plays a very big part in all these things.
Dr. Diwakar then talked about what the main focus of his group and his research is and how can they achieve 3D painting in space.
Yes, so my primary research focus is on understanding these fluid flow phenomena in microgravity conditions. So as I told you, I did my postdoctoral work where we developed experimental setups and we had flown in the microgravity payload, the platform, which is basically an aircraft. So you take it at a particular height and then you put it at an inclination and you cut off the engine. So it will undergo a parabolic path, and during that time, the centrifugal force will balance the gravity and you will emulate the microgravity conditions. That means you will experience weightlessness. Okay. So in that scenario, you would like to understand how the fluid flow behaves. And so that's where I started, and over more than a decade I have been working in this area. And even currently we work on developing a payload for Gaganyaan, the uncrewed mission of Gaganyaan, okay, to understand certain aspects of multi-phase flows. In the long run, the Indian Space Research Organization has a goal of establishing our own space station, like the International Space Station. So as a precursor to that, we have space capsule that will go around the Earth, what we call as a LEO, it's a low Earth orbit, okay? And we have upcoming missions where we are planning to send humans in these capsules, okay, who will spend a day or so, okay, and come back to Earth, okay? And as a precursor to that, so we have some trial experiments that will happen with uncrewed modules, okay? So in such uncrewed payloads or missions, okay, we have one experiment that's been sent as a part of from my institute, JNCASR, where we're trying to understand some multi-phase fluid flow phenomena, basically to understand how vibrational instabilities evolve in these fluids and how thermoconductive instabilities evolve in these fluids. And so apart from this, I'm also part of the IIT Madras Center of Excellence for extraterrestrial manufacturing in space. Because, of course, when you have this sort of space stations or futuristic space missions where we have an outpost in Moon or outpost in Mars, okay, you cannot manufacture everything from Earth and take it there. So you would like to do things in situ. That means with whatever resources that are available there, one would like to build systems there and sustain a living. Okay? So this is the focus of our group, where we are looking at how do you manufacture things in space. Okay? So our primary focus is to look at how to do 3D printing in space, particularly 3D printing of optical components. That means for many astronomical experiments you would need lenses, and the problem is with these lenses, if you manufacture in space, you have to carry them to space safely, because the launch loads, when the rocket lifts off, the loads are very high. There is a potential for their damage. And what we are trying to do is, you don't have to worry about that. You take the raw material with you. You print these materials in space for use in space.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms. आइए हम सुने विज्ञान की अनकही